Hello everyone, welcome to Augment Tech. In this session, we'll be learning about Python C1 matrix plots, grids, and regression plots. By the end of this session, you should be able to understand what matrix plots are, heat map, cluster plots, grids, facet grid, join grid, regression plots, aspect and size, style and color, and scale and context. I'm excited to get started and I hope the same from you. Let's get started with matrix plots. Matrix plots allow you to plot data as color encoded matrices and can also be used to indicate clusters within the data. Now let's see what are heat maps. In order for heat map to work properly, your data should be already in the matrix form. The sns.heatmap function basically just colors it. So here we can make use of the tips dataset available in Seaborn. So here we find the correlation, that is matrix form for correlation of data, and then we can create the heat map for the correlation. So there we go. This is how the output looks like. So in the plot, we have some colored grids. So if you see, the value ranges from 0.5 to 1, and 0.5 is the darkest value here, or something below it is the darkest value. So you can see these two takes lesser value, whereas the lighter grids take more value. So lesser the value, darker the grids, and lighter the color, more the value. Now let's see what is the anat in heat map. So we can also do the numbering on the heat map. So you can see 0.6, we have diagonals as 1, and then we have 0.68, 0.49, and so on. So here we are using the CMAP, that is color map, as the cool warm on the same tips dot correlation data, and then we say anat equals to true, because of which you should be able to see the actual values on this heat map. Again, if you see, here we have 1 as the dark red color, 0.68 falling somewhere here, and then we have 0.49 falling somewhere here. So ANIT is basically going to represent the values on the heat map. Now, if you look at this heat map, let's say this heat map, we're working on flights data set available in CPON, and we're creating a pivot table of it, where it takes values as passengers, index as month, and columns as year. So there we go. You see, these are the months and these are the years, and more number of passengers, lighter the color. So you can see somewhere here, year 1960, in the month of August and July, we had maximum number of passengers. Now, if you look at this heat map, here we have just given a color map as magma, and then line, color, and red, because the previous heat map was not properly visible. The colors were actually overlapping. So here we are providing the color lines. If you see, the color line between this smaller grids are white, and then we have line width as 1. Again, if you see here, more number of passengers, lighter the color. So again, in 1960, August and July, where we had maximum number of passengers, and here somewhere here we have less number of passengers, like 1949, November, October, September, somewhere here we had less number of passengers. Now let's see what is a cluster map. So the cluster map uses hierarchical clustering to produce a clustered version of the heat map. So here we do sns.cluster map. Let's say we are going to create the cluster map of pivot table of flights data set, and this is how the cluster map looks like. So again, if you see here, we have the scale of values, that is number of passengers, and you can see this is how the cluster map looks like. So here it is forming clusters based off the values and the colors. And now we can notice how the colors and months are no longer in order. Instead, they are grouped by similarity in value, that is the passenger count or number of passengers. That means we can begin to infer things from this plot, such as August and July being the similar. So here, if I uh, if we take into consideration July and August, they are like pretty much similar. And then the scale can be changed from 0 to 1 by specifying a parameter standard scale equals 1 to our SNS dot cluster map. So this is how the output of cluster map looks like. Now let's see what are grids. Grids are uh, general types of plots that allow to map plot types to rows and columns of a grid. This helps create similar plots that are separated by features. So we have pair grid, which is a subplot grid for plotting pairwise relationship in a data set that works on bivariate data. So if you do SNS.pair grid and then pass the data set to it like iris, so it should be just giving us the grid. We can map to the grid by doing map, and then we can specify plt.scatter, or we can also map to upper, lower, and diagonal by doing map underscore diag plt.hist. So here I want diagonals to be histograms, and then map upper, the upper plots to be scatter and the lower plots to be KDE plot. Now let's have a look at what a pair plot is. Pair plot is a very simple version of a pair grid that is going to give us the pairwise relationship between the columns. And then we do sns.pair plot of iris. And then we can specify the parameter hue on the categorical column, like species would be the categorical column here. And the color palette that we're using is a rainbow. Now let's discuss what is a facet grid. So facet grid is general way to create grids of plots based off a feature. So here if we say sns.facet grid, and then we can specify the rows and columns here. And also we can map it to a histogram, or we can also map to a scatter plot and then add the legend. Now let's see what is the join grid. So it is general version of join plot type grids. So here we do sns.join_grid, and then we pass x and y variables and then the data set. We can also map this or plot this join plot for reg plot and dist plot. And now let's have a look at the regression plots. So Seaborn has many built-in capabilities. It comes with a lot more capabilities for regression plots. So LM plot allows you to display linear models, where LM stands for linear models, but it also conveniently allows you to split up those plots based off features as well as coloring the hue based off the features. So here we can do sns.lm plot, to which we can pass two variables and then the data set. Also, we can use the hue parameter based off a categorical variable, and then we can also color using the color palette. Now let's have a look at the differences between reg plot and LM plot. So reg plot versus LM plot functions to draw linear regression models. So there are two main functions in Seaborn that helps to visualize a linear relationship determined through regression. These functions are reg plot and LM plot. So regplot will accept the x and y variables in variety of formats including simple numpy arrays, panda series objects, or references to variables in pandas data frame, whereas lmplot has a data required parameter and the x and y variables must be specified as strings, and this data format is called long form data. So these are the differences between regplot and lmplot. Now let's see using a grid. So we can add more variables, a separation through columns and rows using grid. Just indicate this with row or column arguments. So here we can do lmplot, then specify the uh, x value, y value, the data set, and the column value. So column here is basically the categorical variable, and then we can also specify row and column and then the data sets, and then we can also make use of the parameter hue and then the color palette. Now let's see what is aspect and size. So seaborn figures can have their size and aspect ratio adjusted with size as well as aspect parameters. So here we do essence.lmplot, to which we pass x and y variables, dataset, column, hue, palette, and additionally we can also pass aspect and the size parameter. And then you can also use matplotlib's plt.figure fixed size equals width comma height to change the size of most of the seaborn plots. So fixed size is a parameter that we can use in matplotlib in order to specify the width and height of the plot. You can also control the size and aspect ratio of most of the seaborn grid plots by passing in parameters like size and aspect. So we can say plt.figure fixed size equals, and then we can specify the value for width and height, and also we can specify for non-grid plots like count plot, we can just specify the x and then the data set, and then for the grid type of plot we can create lm plot and then x variable, y variable, size parameter, aspect parameter, and then the data set. Now let's see what are style and color. So you can you can set this particular styles. So we can do something like sns.set underscore style is the parameter which is going to take the style. So here we can do text, or we can even despine or remove the text or remove the style. Now let's understand what scale and context is. So the set context method allows you to override default parameters. So here we can do sns.setContext and then pass in the font scale and then plot a count plot by specifying x variable, dataset, and the color palette. Now let's hop to Jupyter Notebook and check out the example of matrix plots, grids, and regression plots. I'll see you there. Here on my Jupyter Notebook, under the Seaborn folder, I'm going to create a new notebook, Python notebook, and let's name this as matrix plots. And let me write a heading saying matrix plots. So let's first discuss the matrix plots. So here I'll be importing the modules or libraries first. Let's say import matplotlib.pyplot as plt, and then import seaborn as SNS. And then here I'll be loading the data set, let's say tips data set and flights data set. So here I'm gonna do tips equals snes.load underscore dataset. That's a tips, and then I'm gonna do tips.head so as to see the first 5 rows of the tips dataset. And there we go. This is our tips dataset having columns like total bill, tip, sex, smoker, day, time, size. Out of all these, total bill, tip, and size are numerical columns, whereas sex, smoker, day, and time are categorical columns. So for categorical columns, you'll have fixed set of values to choose in. Like for sex, it could be male or female. Smoker could be yes or no. Day is days of the week, ranging from Sunday to Saturday, and then time of the meal as dinner, lunch, breakfast, and so on. Now I can also go and do tips.tail, which would give me the last 5 rows, and then tips.info should be giving me information about the columns, whether they are missing values, what type of data the columns are holding. So you can see the column names, non-null count. We do not have any missing values. That is why it is same. That is 244. And then the data types you see for total bill tip, it is float 64. For size, it is in 64. And for all others, it is category. And then I also want to look at the descriptive statistics by doing describe. So this would automatically exclude the categorical column. So it will only give me tips, total bill, tip, total bill, and then it should be describe. And there we go. Total bill, tip, and size. So it only does the descriptive statistics on the numerical column, like finding the count, mean, max, min, standard deviation, and so on. Now I'm gonna load the flights data set. Before that, let's see how we can find like what all data sets are available in Seaborn. So I'm simply gonna do snes.get data set names, and let's go and check if this works. I'm not sure though, but let's go and check. There we go. So when I do snes.get underscore data underscore names, you should be seeing all the built-in data sets available in Seaborn. So somewhere you should be finding tips, and then we have iris dataset, flights dataset. Apart from that, we have this Titanic, exercise, diamonds, brain networks, attention, and so on. So these are the built-in data sets available in Seaborn for us to do the visualization. So now I'll be loading my flights data set by doing flights equals snes dot load underscore data set and then pass in the flights. So here the flights is the data frame, and if I only go and do flights, that is data frame dot head, and there we go. You see, this is the data set or the data frame, flights data frame. Here we have year, month, and the passengers that are boarding the flight. Now I can also go into flights dot tail. That should be giving me last 5 rows. So total we have like 144 rows because it starts from 0. You see last value here is 143. I can also do flights.info. Info basically will return me the column name, the non-null count, and the data type. So if you see here, month is the category. That is, we could be picking up value from January to December. And then year and passengers are in 64. If I do flights dot describe, I should be here saying only the numerical columns, year and passengers. uh, for the descriptive statistics, it will exclude the category column. All right. Now, I'm going to find the correlation of the tips data set by doing tips dot correlation, and there we go. This is what the correlation of tips data set is. You can see total bill with total bill is 1, tip with tip is 1, size with size is 1, the diagonals are 1, tip total bill with tip is zero point 0.6, total bill with size is 0.5. Same here, tip with total bill is 0.6, tip with size is 0.48, size with total bill is 0.59, as we have a size with total bill here, and then tip with size is 0.489. So I simply want to first ignore these warnings by doing import warnings, and then warnings dot filter warnings, and then let's say ignore, and there we go. You see the warnings are ignored now. So now what we have to do is we actually have to create a heat map for this correlation. So how do I do this? sns dot heat map, and then I can pass tips dot correlation, and there we go. This is how the heat map looks like. So here you can see for total bill we had value 1, so that is the highest value of all. So the color is a light here, that's kind of cream color. And if you notice here, tip with total bill is 0.67. Tip with total bill, let's go and check tip with total bill. So this is falling for under here, like 0.67 is somewhere around here. And then if you notice here, total bill with size is 0.59. So total bill with size is 0.59. It is somewhere around here. And then if you notice, tip with size or size with tip is 0.48. So if you go and check tip with size and tip size with tip is 48, that is the darkest of all. It is below 0.59. It means it falls here. So this is how you can create a heat map, or you can plot a heat map on the correlation of data set. So here correlation actually defines how the two columns are correlated with each other. Now if you want to see the values on the plot itself, then you can specify and equals to true. Let's see how to do that. So here I say sns dot heat map, tips dot correlation, and then here I say hue. So this is not hue, this should be a color map. Let's say cmap equals cool warm, and then at this moment this will only change the heat map color. It is not showing us the value. You see this is the uh, color palette or color map for cool warm. If I only do and it equals true, then you should be seeing the values on the grids here. So you see 111, 0.86, 0.68, 0.6, 0.49, and so on. Now let's create a pivot table of flights data set. So here I'm gonna do flights dot pivot table, to which I'm gonna pass values is equal to passengers, and then index equals month, and then columns equals, let's say, year. All right, so this is the pivot table we got by passing values as passengers. So these are my values, that is number of passengers. Index is the month, you can see it's from January to December, and the columns are year from 1949 to 1960. Now let's create a heat map of this. So here I'm going to create variable. Let's say the variable name is PV flights. I'm going to pass this pivot table or assign this pivot table to my variable. And if I go and check flights, I should be seeing the same output. And now on this PV flights, I'm gonna plot the heat map. I can do SNS dot heat map and then PV flights. And there we go. This is how the heat map for uh, flights dataset pivot table looks like. So here if you notice, we have on the scale 600 or more. Here we have the lesser value. It means the color where we have uh, lighter color has more number of passengers, maybe 600 or above. So it falls for year 1960 and in the month of July and August. And if you notice below 200 we have darker shades, so if it means these are like kind of blue, below 200, among which let's say these are the uh, you know these are having the less number of passengers, like 1949 November, 1950 November, and then 1949 and 1950 February. All right, so now we can do a little more customization on this, because if you see here, the colors are kind of overlapping. So I'm gonna do a little more of customization here by specifying the line width and line color. So I'm gonna do sns dot heat map, and then I'm gonna say PV flights, and then CMap is, let's say, magma, line color is, let's say, white, and line width is, let's 1. There we go. This is how the output looks like. So here you can see the colors are not overlapping, and we have a nice heat map with very appealing visualization. So if you see again here, the lighter blocks that have uh, lighter shades are like having passengers more than 600, whereas the darker shades are having passengers less than 600. You can also go and check here. If you notice here, July and August 1960, you have 622 passengers and 606 passengers. They are the highest number of passengers from all the data or values available. And if you check here in November 1949 and somewhere here like January 1949, here we have less number of passengers traveling. Now let's see what is a cluster map. So here I'm gonna write a heading saying cluster map. And a markdown that says cluster map. So it should be cluster. Cluster map uses hierarchical clustering to produce a clustered version of a heat map. So here I can do sns dot cluster map of PV flights, and there we go. The cluster map looks like this. And here it actually makes use of the hierarchical clusters to just give us the cluster version of the heat map. So you can see here it is forming clusters for the similar kind of colors, or specifying the values of number of passengers. So if you notice here, we have the scale that is 200 to 600. Number of passengers below 200 is giving us the darker shades, that is hopefully inside the same cluster. And then here we have passengers like 600 above or above, having the lighter shade that falls here for July and August 1960. So you see lighter shades are in one cluster. Now what if I do something like this? If I do ss dot cluster map, let me change. Here I say PV flights, and then CMAP equals, let me take cool warm, and then I'm going to specify the standard scale here. So standard scale equals, let's say 1, and you should be seeing the standard scale values have been now changed to 0.0 to 1.0, and this is how the cluster map with cool warm color map looks like. You can see different variations of colors depending on the standard scale. So again, the darker red color meaning more number of passengers traveling. So it's again in the month of July and August 1960. If Alright, so this was about a cluster map. Now let's go and see what are grids. So for grids, I'm going to create a new notebook. So I'm going to go back to my Seaborn folder. I'm going to create a new Python notebook. Let's name this as grids. And let's specify the heading as grids here. So I'm gonna say grids, and a markdown that says grids are general types of plots that allows you to map plots, map plot types to rows and columns of grid. And this helps you create similar plots. Those are separated by features. So here first I'm going to import matplotlib and Seaborn, that is the required modules or libraries for visualization, that is matplotlib.pyplot as plt, and then import Seaborn as SNS, and then I'll be loading the iris data set available in Seaborn. So here I say iris data frame equals sns dot load dataset and then iris. Let's go and check iris. I'm taking the data frame iris. So there we go. This is the iris data set available in Seaborn, having 150 rows and 5 columns. So columns are sepal length, sepal width, petal width, and species, out of which species is only the categorical column and rest others are numerical columns. If you just look at them, look at the values, and you can understand that these are numerical columns. So now I'm gonna simply do iris dot head just to see first 5 rows, and there we go. These are the 5 rows, and if I want to see the last 5 rows, I can simply do iris dot tail, and there we go. These are my last 5 rows. You can also do iris dot info so as to get the information about the data type of the column. So there we go. You see here, again, species here is not a categorical, but it is an object. Um, so yep, it could have multiple values or multiple species, because of which it is like object, that is string data type, and rest others are numerical, that is float 64. If I do iris dot describe, I should be seeing only the columns like sepal width, sepal length, petal length, and then exclude the species column for the descriptive statistics. And there we go. This is how the output looks like. Now let's see what is a pair grid. So here I'm gonna write a markdown for pair grid, saying pair grid is a subplot grid for plotting pairwise relationships in a data set. Now let's see how to do that. So here I do sns dot pair grid of iris. There we go. This is only creating a grid for us without any plots on it or without any points. Here I'm gonna do g equals sns dot pair grid of iris. Oh, this gives me an error. Let's see. Okay. So it's a string, integers must be integer. Okay. So it means that this should not be in quotation. And let's go and check. And there we go. This is the diagonal, which are histograms. And then the upper are scatter plots and the lower are KDE plots. All right. So these are my histograms. These are mapped using map tag, and this is map underscore upper, and then this is map underscore lower. These are scatter plots, and these are the KDE plots. Now let's see what is a pair plot. So here I'm gonna write a markdown for pair plot, saying pair plot is simpler version of pair grid. Make sure to write the G caps for pair grid, and then I can do sns dot pair plot of iris dataset or iris data frame, and then there we go. This is how the pair plot for iris dataset looks like. Again, if you see, the diagonals are histograms and all others are scatter plots. So this is again showing us the pairwise relationship between the columns of the iris data frame. Now I can also do something like this. I can say sns dot pair plot. I can specify the hue as well as the color palette. Let's quickly do that. So here I'm gonna say iris and then hue equals species. Species here is the object column, and then palette equals, let's say, rainbow. Because the plots are big, it might take a little while to display. There we go. This is a nice looking pair plot with rainbow palette, and hue here is species. So if you see, the species here are Setosa, versicolor, and virginica. So based on this hue, it's actually plotting. So here you can see the blue points denote a Setosa species, versicolor is denoted by green color, and then virginica by orange color dots. So that was about the pair plot. Now let's go and see what is a facet grid. So I'm gonna write a heading here saying facet grid, and then a markdown that says facet grid is the general way to create grids of plots based off the feature. So here I'll be loading the tips data set. So I'm going to simply do tips equals load underscore data set, tips, and then tips dot head. This should be sns dot load data set, and there we go. This is the tips data set. So now we just created a data frame for the tips data set. Now what we'll do is we'll say g equals sns dot facet grid, passing the data frame, column, and rows. Let's say the column is meal time and row is the categorical column smoker. Let's go and check the output for this. Alright, so you can see here we just got the grid without any points on it. So now what I can do is I can do g equals g dot map, and then I'm gonna plot plt dot hist on total bill. And then I can go and check g. So you should be seeing hist plotted upon the grid. So let's go and see. So here I'm gonna do dist plot. Let's say plt dot dist plot, and let's go and check. And this plot comes from Cbond, so this should be sns dot dist plot. And you see this is how this gives me a warning here. Alright, so let's ignore this, and what we will do here is, here we go. So here I'm supposed to pass data equals tips, and you can see for the column row, a column in row, column time in row smoker, this is how the output looks like. So this has been plotting total bill versus tip for a smoker, and the column is a time, that is smoker S, and then time lunch, smoker S, or time dinner. And this is for smoker, no non-smoker, time is lunch, and non-smoker, here time is dinner. So now what we can do is we can go and check for this plot of this and see the output. So again, I'm gonna say tip, or we can also have a plot for a scatter plot for total bill and a tip column. Now let's see what is a joint grid. So here I'm gonna say joint grid. So let me change this to markdown, saying joint grid is a simpler version of joint plot type grids. And here I'm gonna do g equals snes dot joint plot, to which I can pass x equals total bill, and then y equals tip, and then data equals tips. Alright, so this gives me some error. Alright, this should be joint grid and joint, not joint plot. So here I'm gonna say caps G, and then this should be joint grid. And there we go. This is how the output for joint grid looks like. Now this is about the grids. Now we'll see what are regression plots. So I'm gonna open the I'm gonna go back to the folder. Now here I'm on my Jupyter notebook and C1. Under C1 folder, I'm gonna create a new Python file, and let's name this as Python file or notebook, and let's name this as regression plots. So let's quickly rename this as regression plots, and then a heading for regression plots. So what I'm gonna do, regression plots, and then a markdown that says regression plots. So regression plots are actually the main concept of machine learning. So we will be discussing this in depth in machine learning module. But in terms of visualization, Seaborn has many built-in capabilities for regression plots. On regression plots, we will be discussing about LM plot, which is linear model plot or linear model function, which allows to display linear models. Now let's import the required modules or libraries. So first I'm going to import matplotlib.pyplot as a PLT, and then import Seaborn as SNS. And then here we'll be loading the tips dataset available in Seaborn by doing tips equals load underscore dataset. That should be SNS dot load underscore dataset. So tips here is the data frame that I'm creating using this tips dataset, And then I'm going to do tips.head so as to get first 5 rows. Okay, so here it is matplotlib, and let's run, and there we go. Now I'm gonna simply plot the linear model plot. So here I'm gonna write a heading for lm plot. Let's say this is lm plot. Here I'm gonna do snes.lm plot x equals total bill, and then y equals tips. Sorry, tip, not tips. Tip is one of the column, and tips is the actually data frame or data set name. And then pass in the data frame name as tips, and let's check. There we go. This is how we got the output. So here we have the regression line. If you see, this is the linear model. So you could see points which are exactly pointed on this regression line, or points which are away from the regression line, or the points which are close to regression line. So this is actually uh, a plotting of the tip versus a total bill, where you could see the bunch of points are exactly on the line, on the straight line or close to the straight line. So it means these are the dense points where the value for tip is more with respect to total bill. And if you see between 10 and 20, the points are more like 20 and 30, quite better. 30, 40, okay. And then 40, 50, you could hardly see the points, and all points are scattered away from the straight line. Now we can also make use of the hue parameter, like how is the behavior with respect to the sex column. So here I'm going to do lm plot x equals total bill, y equals tips. Sorry, this should be tip and not tips. And then I'm going to say hue equals sex column, that is, it should be plotting based off male and female, that are the categories of the sex column. And then I could say data equals tips, and let's run and check. There we go. This is how the output looks like. So here you see the blue dots are denoting males, and the orange color dots are denoting females. And significantly, if you look at the total bill for male is more than female, as well as the value for tip based off total bill is significantly more for males than for females. So you can see here we have two lines, one for the male, the other for the female. So male is starting somewhere from here, and then female is actually starting from somewhere here and ending by here. Let's say this is the point where was the max tip with respect to total bill for females, and for male this is the point. So this was the LM plot based off the hue parameter. These are the default colors for male and female. I could also go and change by specifying the palette. So I'm going to again do snes.lm plot, and then x equals total bill, y equals tip, data equals tips data frame, and then hue is sex column, and then color palette is, let's say, cool warm. This time you can specify any color, any color palette you want. So there we go. This is how the output looks like. You can see only the change of color from the previous output. Also in this plot we can change the markers for male and female. Right now both are rings. I could just change the markers. Let's try doing that. So here I say snes.lm plot, and then x equals total bill, Or let me get this from the above. And here I'm going to say markers equals, I'm going to provide list of markers here. Let's say the list of markers are O and V, and then I can specify the scatter KWS equals S colon 100. And now let's check the output. There we go. You see the marker for female has been changed to V. The marker for males are O, that is ring, and also the size of the marker has been significantly increased. Now we'll see how to make use of the grids. So here I say using grids. That is, here in the LM plot, we'll be making use of the columns. So here I'm gonna say we can add more variable separation through columns and rows with the use of grid. So here we just need to add, here we can indicate this with rows and columns argument. Let's say I'm gonna do snes.lm plot x equals total bill, and then y equals tip, data equals tips, and then column equals, let's say, sex column. Let's go and check the output for this. And there we go. You see, this is actually plotting for different plots for male and female, because I've specified the column as sex, which is a categorical column having two categories, male and female. So you can see the points in male plot are significantly more than the points in a female plot here. And because the number of males are more, you can significantly see the tip value more based on the total bill, and here significantly less tip value based on the total bill for females. Now let's also have the row specified. So I'm going to do snes.lm plot, and then x equals total bill, y equals tip, and then data equals tips, row equals, let's say, this time row is sex, and column is the another categorical uh, column, time. All right, let's go and check the output. So in this example, I've also specified rows and columns. So you should be seeing here we have two rows and two columns based on sex and the time, that is the meal time. So here for sex male, the time is lunch. For male, the time is dinner, and then for female, the time is lunch, and for female, the time is dinner, and it is plotting the LM plot for total bill versus tip based on male and female, that is the sex column, and the uh, time column. So here we are making rows for male and female, and the columns are for the time of meal. To the same, I can also go and change the color palette so as to have a differentiation or more appealing visualization. So here I'm going to say cool, warm. Let's go and check. And or let's not have the palette here. Let's Let's now this time use the column as day, and we have to also have the hue in order for the palette to reflect. So I'm gonna say sns.lm plot x is total bill, y is tip, data is tips, and then column is day, and then I need to have hue. Let's say hue is 6, and palette equals cool warm. Let's go and check this. Okay, so this should be sns.lm plot. It says tip is not defined. This should be in quotations because it's the name of the column. And there we go. This is how the output looks like. So for hue, sex, that is for male and female, you can see the palette is cool, warm, and the grids or the columns here are for days. So this is column 1, column 2, column 3, column 4. Where this is Thursday, this is Friday, this is Saturday, and this is Sunday. And this is plotting total bill versus tip for males and females and on each of these weekdays. Now let's see what are aspect and size. So here I'm going to write a heading saying aspects and size. So seaborne figures can have their size and aspect ratio adjusted to the size and aspect parameters. So here I'm going to do sns.lm plot, and then x equals, let's say, total bill, y equals tip, data equals tips. Let's say column is day. To the above plot only, I'm going to extend this aspect in size, qsx, palette is again full warm, and then let's say aspect is 0.6 and size is something like 8. Let's go and check the output. Okay, there's a typo here. And there we go. This is how the output looks like. So here I've specified argument as aspect equals a 0.6. You can also go and change the aspect to, let's say, 1 and see. You could be seeing more compressed view if I say 0.3. Yes, this is more compressed than the previous one. All right. So let's say here we have aspect as 6.6. Alright, so this was about aspect and size. Now let's go and see style and color. So I'm gonna write a heading here saying style and color. So we can control the figure aesthetics in Seaborn by using style and color. So here I'm again gonna import all the required modules and libraries. You don't have to do this again and again. Once you have done, that's okay. Tips equals load ss dot load underscore data set, and then this is tips, and then tips dot head. All right, so now we'll see the style, how to set the particular style. So here I'm gonna write a heading for style. and let's say a markdown. Let's set particular styles. So here I'm gonna do SNS dot count plot. It should be count plot x equals x. So this is univariate analysis. So this should be giving me the count of males and females. There we go. This is how the output looks like. And you see, we have males somewhere around 160, maybe 158 or 159, and then females like somewhere around 100. So I can set the style saying sns dot set underscore style. I want to specify the ticks here, and then sns dot count plot, and then x equals, let's say, 6, data equals tips, and then palette equals, let's say, autumn. Let's go and see the output. Oops, it should be giving me an error because there was a typo. Alright, so this is how my output looks like. So if you could see here, so we do have the ticks. That is, we have set the ticks by doing sns.setStyle, or by default, if you're having ticks, you can just despine and remove it. Now let's see how to do that. I can simply do sns.despine and see. I also not need to specify this. Alright, so now what I can do is I can simply do something like left equals true and check the output. So you can see this is actually removing the y-axis and it's only giving us the ticks. So that is known as despining. So you can specify any palette you want. You can despine or set the style. If you have background gray in default, you can change it to white by setting the color. Or let me try that once. So here I go. Get this again. And this time I'm gonna do, just gonna check if this works. Let's say this is blue or something. Oh, this is not one of the style though. If I say white, it should be working but giving me the same because I already have the background to be white, and you can see this is actually displaying in the form of a nice box, right? So when I did this despine, you should see this box has been changed to only x and y axis, and when I did despan left equals true, you should be seeing this has been gone. Now let's discuss the size and aspect. So here if I say size and aspect, we'll first discuss this for like matplotlib. Not in matplotlib, we have plt.figure, and then we specify the fixed size equals the width and the height. So here for non-grid plot, so here I'm gonna say non-grid plot. I can say plt.figure, and that to which I can pass fixed size equals, let's say the width is 10 and the height is 3. And then I can do sns dot count plot of x equals 6 and then data equals tips. should be count plot. And there we go. This is how the output looks like. So here you see the width is quite large because 10, the value specified 10, and you can see the height is 3. So if I only go and specify a lesser value, you should be significantly seeing a narrower bars than the broader ones. Alright, so this is about a fixed size. We are using the fixed size attribute of matplotlib in order to specify the width and a height of the count plot bars. Now let's have a look at the example of grid type plot. So here I'm going to say grid type plot, and then let's make use of lm plot. Let's say x equals total bill, and then y equals tip, then data equals tips, size 2, aspect 4. Let's go and check if this works with size parameter or no. Okay, this doesn't take size, so let me only check with aspect if this works. Alright, so this is how the output looks like. Now lastly, we'll see what is a scale and context. So I'm going to write a heading here for scale and context, which would eventually override the parameters. Here I'm going to do SNS dot set context, and then let's pass value poster to it, and then font scale, let's say a 4, and then SNS dot count plot x equals 6, data equals tips, and then palette equals, let's say, cool warm. Let's go and check. There we go. This is how the output looks like. So you can see it's actually changing the size. The context here is poster, and the font scale is changed to 4. You can see it's like overriding the default size values. Alright, so this was all about the LM plot and regression plots. So here we have seen like how to create the LM plots based off the hue, changing the markers, and then aspect and size style, setting the style, and also setting the context. So in this session, we have seen what are grids like facet grid, join grid, pair plots, and then we have seen the matrix plots like heat map, cluster map, pair plots, and pair grids. So that's all for this session. Hope you enjoyed the session. We'll see you in the next.